Okay, these are the introductory problems for momentum and impulse. Let's go to number one. A baseball of mass 0.14 kilograms is moving at 35 meters per second. So we are given the direction. It's positive, heading to the right. Okay, the mass of the baseball is 0.14 kilograms, and the V is positive 35 meters per second. You are asked, find the momentum of the baseball. So our formula is P equals M times V. The mass is 0.14 kilograms. Multiply this by positive 35 meters per second. Now, momentum is a vector quantity, so we have to indicate the direction. 0.14 times 35, we get 4.9. Okay, this is going to give us positive 4.9 kilogram meter per second. Okay, or you can say 4.9 kilogram meter per second to the right. Then for letter B, you are asked find the velocity at which a bowling ball mass 7.26 kilograms would have the same momentum as the baseball. Okay, so we are looking for the V, no? But this time we change the mass 7.26 kilograms. So P is equal to M times V. What we are looking for is the velocity. So V is equal to P divided by M. The same as letter A. So we substitute positive 4.9 kilogram meter per second. But this time it's a different mass divided by 7.26 kilograms. Okay, so what is 4.9 divided by 7.26 kilograms? This will give us 0.67. So positive 0.674 okay, meters per second. Then um, we round this off to 2SF, so we get 0.67 meters per second to the right, or just indicate the positive sign, okay, for the direction of velocity. Number two, a 0.144 kilogram baseball is pitched horizontally at positive 38 meters per second. After it is hit by a bat, it moves horizontally at negative 38 meters per second. So there is a change in the velocity. Initially, it is heading to the right, and then final heading to the left because it was hit by a bat. The question, what impulse did the bat deliver to the ball? Okay, we know that the impulse J is measured by the change in the momentum. Our symbol for momentum is the capital letter P. So it's going to be PF minus PI. Okay. We expand this equation, you get M VF minus M VI. We can factor out the mass. You have V final minus the V initial. Now the mass is given 0.144 kilograms, and the V final is negative 38 meters per second minus the V initial, which is positive 38 meters per second. Okay, what do we get? Times 0.144. The answer is negative. The change in the momentum, or J, is negative 10.944. The unit would be kilogram meters per second. So meters, kilogram meters per second. This can be rounded off to negative 11 kapag 2SF. Okay, in letter B, this should be letter B. If the bat and the ball were in contact uh, for 0.80 seconds, okay, so 0.80 seconds. The unit should be seconds because this is time. What was the average force that the bat exerted on the ball? Okay, so we know that the formula J is equal to F times T. So we are looking for F. F is equal to the J divided by the T. So the J that we computed is negative 10.944 kilogram meters per second. Then we divide this with the time, 0.80 seconds, the time in contact. So the unit here is 0.80 seconds. So let us compute that divided by zero point 0.8. The answer that you are going to get is the F is negative 13.68 newtons, because the unit that you will get here when you divide J and T is kilogram meters per second squared, which is the unit of Newton. We follow 2SF, so you are going to get negative 14 newtons. Expressing it in scientific notation, negative 1.4. Okay, sorry, this one should just be negative 14 newtons. Okay, letter C. This one should be letter C. So A, B, C. Find the average acceleration of the ball during its contact with the bat. So we already solved for the F. We know that F is equal to M times A. Here we are looking for the acceleration. So A is equal to F divided by the M. Okay, so we substitute the value of F, which is negative 13.68 newtons, the one that is not rounded off, divided by the mass, which is 0.144 kilograms. So 0.144 kilograms. The answer that we are going to get is around negative 95 meters per second squared. Okay, so this one is wrong. So it should be negative 9.5 times 10 raised to positive 1. But this could already be your final answer. Pwede na ito. Okay, so hindi naman niya sinabi that you have to answer in scientific notation. Okay. Number 3, the brakes exert 6.4 times 10 raised to the second Newton force on a car weighing 15,680 newtons and moving at 20.0 meters per second. So this is problem 3. What is the car's mass? Okay, so we are given the F. It's a braking force, so we expect that should be negative 6.4 times 10 raised to the 2 newtons. No, the weight of the car is given. Okay, from here we can compute for the mass of the car. Okay, the mass of the car is can be solved by converting 15,680 newtons. Okay, so 9.8 newtons is 1 kilogram. What is 15,680 divided by 1.6 exp 3? Okay, we are 15,680 divided by 9.8. We get 1,600. Sorry, this is 1,600 kilograms. Okay, you can express it in SF, in scientific notation, SN, okay, if you want it. But this could be your final answer, 1,600. So letter A is just a conversion problem. It's asking for the mass of the car given the weight. Letter B, what is its initial momentum? So P is equal to M times V. We have already solved for the mass. It's 1,600 kilograms. Okay, we multiply this with 20.0 meters per second. Okay, so times 20, we get 32,000. 32,000 kilogram meter per second. So you may express it in scientific notation. That would be the answer, 3.2 times 10 raised to the fourth. Now, how many SF should the answer be? It should be in 3 SF kasi 3. This is already 4, and then this one is 3. So dapat 3 pala. We have to put a bar here. And this one, you can put a bar here. Or you can express it in scientific notation. It's already in 3, and this one is already in 3SF. Okay. Letter C, what is the change in the car's momentum? So what happened? Nag-stop kasi siya. The car finally stops. So we have the V final is equal to 0. Okay, so the V final is equal to 0. So in the change in momentum, we have M VF minus the V initial, okay, the VI. Okay, we have the V final 0, so this becomes 0. You will have a negative answer, negative M VI. Okay, that is the change in momentum. But we have already compute for M and VI. Okay, the value is here, 32,000, di ba? So 32,000 kilogram meter per second. So we just put the negative sign, negative 32,000 kilogram meter per second. And then, three significant figures. So, lagay natin ng bar sa taas ng 0. Or you may express it like this. In letter D, how long does the braking force act on the car to bring it to a halt? So, the formula for delta P, this is also your J, your impulse J, it's equal to F times T. What we are solving for in letter D is the time. Gaano katagal daw in-apply yung force para ma-stop. So, T is equal to J divided by F. The J we have computed. This is also our J, impulse and delta P. J and delta P, they mean the same. So, J is negative 32,000. Okay, is this a rounded off value? No. So 32,000 kilogram meter per second divided by the force. Okay, what is the force supplied? It's negative 6.4 times 10 raised to the 2. Negative 6.4 times 10 raised to the 2 newtons. Okay, so we compute for the time 32,000 divided by negative 6.4 exp2, we get 50.0 seconds. Okay, so all the answers are in 3SF, so 50.0 seconds. Okay,